Hi everyone, in this video we are going to discuss about how to find the general solution for trigonometric equations which are kind of like this that I have on the screen here. Tangent of x equals 0 or tangent of x equals 1 or tangent of x equals negative 1. Similarly, cotangent of x equals 0, cotangent of x equals 1, cotangent of x equals negative 1, and also cosecant of x equals 1, secant of x equals 1, and cosecant of x equals negative 1, secant of x equals negative 1. For this standard trigonometric equations, how to find the general solution, that's exactly what we are going to learn in this video. In the very first video of the trigonometric equation series, we have learned some of the other fundamental trigonometric equations and their solutions, which were kind of like this. There we have learned the general solution of x when sine of x equals 0 or sine of x equals 1 or sine of x equals negative 1. Similarly, cosine of x equals 0 or cosine of x equals 1 or cosine of x equals negative 1. We have learned that the general solution of x would be like this, where of course n is an integer. I don't have that in the note here, but please assume that n is an integer, or maybe I can quickly make a note right here that in all these cases actually n is an integer. It belongs to the integer set. It could be a positive integer, negative integer, or even 0. So n is an integer. Using the general solution for those fundamental trigonometric equations, we are going to see how we can find the general solution for these other trigonometric equations that I have in the green color here, right? So let's get started. Let's first discuss about tangent of x equals 0. When tangent of x equals 0, can we write it as sine of x over cosine of x is equal to 0, because tangent is the ratio of sine over cosine. So from here we can clearly see that sine of x is equal to 0, and when sine of x is equal to 0, what is the general solution? Well, the general solution is kind of like this: x is equal to n times pi, where n is an integer. Of course, please assume that n is an integer. I'm not going to write it every time. Please assume that n is an integer, any integer. So this is the general solution for tangent of x equals 0. Now let's talk about tangent of x equals 1, and this can be written as tangent of 45 degree, which is pi over 4. And in the previous video we have learned the general solution of tangent of x equals tangent of alpha, and the general solution was x equals n times pi plus alpha. So in this case alpha is actually pi over 4. So let me make a quick note here that tangent of x is equal to tangent of alpha gives us the general solution of x, which is equal to n times pi plus alpha. So I'm adding this one other trigonometric equation in the standard list here. So when tangent of x equals tangent of alpha, then the general solution is n times pi plus alpha. So in this case then we can say, well, clearly here x should be equal to n times pi plus pi over 4, and that is the general solution. Now let's talk about tangent of x equals negative 1. Can this be written as tangent of negative pi over 4? We know that tangent of negative pi over 4 will be a negative value, and it will be negative tangent of pi over 4, which is negative 1. So negative 1 can be written as tangent of negative pi over 4. And here again, if we assume that this negative pi over 4 is alpha, then tangent of x equals tangent of alpha, that gives us the general solution like this. It will be x equals n times pi plus the angle, which is negative pi over 4, and this can be written as n times pi minus pi over 4, and that is the general solution. Next, let's talk about cotangent of x equals 0, that trigonometric equation. Can we write it as cosine of x over sine of x? And from here, can we then say cosine of x equals 0? And then from here, can we say that x will be equal to 2 times n plus 1 times pi over 2. So that will be equal to 2n plus 1 times pi over 2. And you can see that in the standard list here that when cosine of x equals 0, the general solution is x equals 2n plus 1 times pi over 2. That's like any odd multiple of pi over 2. Next, let's talk about cotangent of x equals 1. Can we write it as 1 over tangent of x equals 1? And from here we can clearly see that tangent of x is definitely equal to 1, which is again equal to tangent of pi over 4. So here again the general solution will be same as the general solution of tangent of x equals 1, and that was n pi plus pi over 4. So here we can say then x is definitely equal to n pi plus pi over 4, and that's the general solution. Now let's talk about cotangent of x equals negative 1. Can we write it as 1 over tangent of x equals negative 1? and from here we can say, well, then tangent of x is definitely -1, which is equal to tangent of negative pi over 4, and then the general solution would be n pi minus pi over 4. We have seen that up there, that when tangent of x equals -1, the general solution is n pi minus pi over 4. So it's pretty much the same solution. Next we are going to talk about the trigonometric equations involving the cosecant ratio. Let's first talk about cosecant of x equals 1. Can we write it as 1 over sine of x is equal to 1, and from here we can say, well, then sine of x is equal to 1, and then the general solution would be x equals 4n plus 1 times pi over 2. We can see that up there, here you see sine of x equals 1 gives us x equals 4n plus 1 times pi over 2, and that's exactly what I am using here. So when sine of x equals 1, the general solution for x would be 4n plus 1 times pi over 2, and this is the general solution of this trigonometric equation, which is cosecant of x equals 1. So let me highlight that. So this is the general solution of this equation. Next talk about cosecant of x equals -1, and from here can we write it as 1 over sine of x equals -1, and now you can clearly see that this is sine of x equals -1, so the general solution will be exactly same as the solution of sine of x equals -1. So what was the solution there? Well, when sine of x is equal to -1, then x would be equal to 4n minus 1 times pi over 2, and that is the general solution of cosecant of x equals -1, which is exactly same as sine of x equals -1. They both have the same general solution. Let's also quickly talk about secant of x equals 1, which can be written as 1 over cosine of x equals 1, and from here we can say cosine of x is equal to 1, positive 1, and then definitely x will be equal to 2n pi. So the general solution for secant of x equals 1 is exactly same as the general solution of cosine of x equals 1. Also let's talk about secant of x equals -1. It can be written as 1 over cosine of x equals -1. From here we can say cosine of x equals -1, and then the general solution would be x equals 2n plus 1 times pi, which is the general solution of cosine of x equals -1. So they both have the same general solution. I think that covers all of the ones that I noted up above. Let me take a quick look. We had 3 equations involving tangent, and 3 involving cotangent, and then 2 involving cosecant, and 2 involving secant. So we had total 10 of them, and I think we have covered all 10 of them here. I hope everything made sense. Thank you for watching. See you in the next video.